This is the top flap of section number 3 in your Unit 3 quadratic functions flipbook. And this section, the essential question is, how do I graph a standard form quadratic? A standard form quadratic is in the form ax squared plus bx plus c. If we haven't covered that in previous videos, you will see that, and I think we already have covered that. So how do I graph a standard form quadratic? Class, I want you to learn this process, because if you learn this process, it looks like it's a long process, but it's actually fairly quick, and when you get good at it, you can graph a standard form very quickly. So how do I graph a standard form quadratic? Here is our practice one. F of x is equal to 2x squared plus 4x minus 1. And the trick to graphing a standard form quadratic is finding the vertex. If we can find the vertex, then the graph is very easy to complete. So let's go through the steps of finding the vertex, then you'll see how quick this is. Step number 1 says to find, let me get that in green. Step number 1 says to find or identify the values of a, b, and c. And based on the standard form, we know that the 2 is the value of a, the positive 4 is the value of b, the negative 1 is the value of c. And remember, if there's no b term in our function, then b is 0. If there's no c term, then c is 0. So in this case, we've identified that a equals 2, b equals 4, and c equals negative 1. Next step, find the x value of the vertex, and here's a cool trick. We have this formula, negative b divided by 2a will give us the x value of the vertex. Now, since our b value in our function f is positive 4, the opposite of that is negative 4. Now remember, class, if b were negative 4, if this was negative 4x minus 1, then b would be negative 4. The opposite would be positive 4. So this negative sign, we've been learning this all along in IM2. This does not mean that b is always negative. This means because the negative sign or the minus sign is in the equation or in this, I guess we'll just call it equation, then, or this parameter, we can call it parameter, then we know that whatever the b value is, you flip the sign. So negative b is going to be negative 4, and then 2 times the value of a, which is in our case 2. Let's go ahead and finish this. This is negative 4 divided by 2 times 2, which is 4. And so we end up with a value of negative 1. And that, class, is the x value of our vertex. The x value of our vertex. We can actually plug that in our table right now. Let's do that. Here's the x value of our vertex. Actually, you know what? I'm not going to jump ahead. We'll get there in a moment. Step number 3, find the y value of the vertex by plugging in the x value, and solving for y. So now we're going to rewrite our function. F of negative 1, we're plugging in our x value of our vertex. This should now give us the y value. So f of negative 1 is equal to 2 times x value, which is negative 1 squared, plus 4 times the x value, which is negative 1 minus 1. Let's go ahead and solve that. And actually, you know what? Let's not go through the process of doing that step by step. You can use your calculator to go ahead and solve that all in one step. I'm going to go ahead and bring up a calculator right now. See if I can move that off the screen a little bit. And I'll go ahead and do it with my calculator. 2, and then in parentheses, negative 1. Close parentheses. We will square that term. That's going to look different than a lot of your calculators. Don't worry about that. And plus 4. Hopefully you've got yours done already. 4 times negative 1 minus 1. See, this is 2 times negative 1 squared plus 4 times negative 1 minus 1. We press equal, and our answer is negative 3. So we end up with negative 3, and that is the y value of the vertex, the y value. I can take that value now and circle it. Alright, step number 4. That wasn't so hard. We now know our vertex. Put the vertex in row 3 of the table. So we'll go ahead and take this. The vertex is -1 and -3. -1, -3. Now, step 5 is actually pretty easy. Let me go ahead and write down here. This was step 4. Step 5 says, fill in the x column with 2 values below the vertex and 2 values above. So I'm going to go 2 values below, -2, -3, and I'm going to go 2 values above, 0 and 1. Get that 0 closed, and then 1. That's step number 5. I'll put 5 right here. Next step, calculate the y values. So what you do, class, is take every one of these numbers, plug them into the function, and you're going to get out a y value. Do the same thing we did here. You can put the whole thing into your calculator in one expression and press equal, and you'll get the answer. I've done these in advance, and I have a value of 5, -1 when I plug in -2. Remember, x is our input. You plug in 0, out will come -1, and you plug in 1, and out will come 5. Now I want you to notice something very important. There is a pattern here. If we ended up with -1 as our x value of our vertex and went down exactly 1 unit twice and went up 1 unit, these numbers will always be the same because remember, our vertex is on the axis of symmetry. So you'll see a pattern here which makes it very easy to fill out this table. If you plugged in -3 and got 5 and -2 and got -1, you can figure out that these numbers will be the same, just reflected. Now, the reason I'd rather have you plug them in and get the actual value is to catch any mistakes you made up here. So I would still suggest you actually figure out the 5 or the 4 different y values. That is step number 6. Step number 7 says plot the 5 points and connect them to form a parabola. So let's go ahead and plot the points. I've got -3, 1, 2, 3, 4, 5, and -2, -1, oh, that's not -2, -1, let's try it again. Here is -2, -1, -1, -3, 0, -1, and 1, +5. Now it's tough for me to draw parabolas with this drawing tablet, but I'm going to give it a shot. You can do a much better job than I can of drawing these freehand, so please don't draw as messy as I am. And I get delays too, so right now my computer is not caught up with my cursor. So hang on a second while I try to get it caught up. I'll try to correct that now. And through that point, don't forget to put arrows on the ends. Class, couple things to remember. What I just said is true. Always put arrows because as you continued on plugging in tables, these lines would infinitely go up. They would also infinitely expand out left and right. Also, never draw the vertex as a pointy. It's always going to be a curve. So there is a basic sketch of our parabola, and that's the steps of how to graph a standard form quadratic. Find the vertex first. Put it in your table, find 2 points below that x value and 2 points above that x value and plot it. And then look at number 7 says, if it doesn't look like a parabola, then find your mistakes. If you ended up plotting a point out here somewhere, I will tell you, class, you know you made an error, so go find it. Please don't connect the dots of a parabola and have your parabola look like this. If that's what your parabola looks like, trust me, you've got calculation errors in your table. And then one more thing we note, if A is positive, which it is, our parabola better be opening up. And if A is negative, which it's not, but if it were, then our parabola would be opening or pointing down. So make sure that the way the parabola is opening is correct based on the sign of your A value.